Alright, let's check on the geogbra where we sketch the parabola graph. Right, now for us to check the graph, so I've inserted the equation here. F of x equals to ax squared plus bx plus c, where a, b, c are the coefficients and a, b, c are the coefficients or the parameters of our equation. Right, where do we start? We can start by changing the value of a and see the effect. Remember, the value of a is affecting the shape, whether concave up or down. So now a is 0, in this case just showing a straight line along the x-axis in green way. Now let's go move to a parabola. So now if we change the value of a to be positive, look at this one. The value of a is positive, which is 0, 1 in that case, 0, 2. Now there are two things that are happening. So when the value of a is positive and smaller, the graph will become wider. So then let's increase that to 1 to get the what's happening. Now the a is moving to 1. Look at the shape of the graph is decreasing. It becomes less wider. Then that is 1, but it's concave up. So it's a smiling graph. Then now, can you see when the value of a is increasing? Look at when the value of a is 2. Then the graph becomes less wider. And then that's what we have in the shape of a. Now let's go back to 0. Now let's check when here is 0. Now let's check when the graph or it will be like if the a is negative. Now if you start to be negative, can you see that negative? Then the graph is concave down, it's concave down, concave down, it's concave down. Then again, as the value of a becomes less negative or a negative of a bigger number, then it becomes less wider, less wider again. Now that is the effect of a. Now let's go and put a on 1. Let's put a on 1. Right, now that is our graph. As a equals to, so in other ways, it means the graph is f of x equals to ax squared in that case. And now we need to check the effect of b together with a being positive. Remember already, the b will change what the effect that was done on the a. So then they have a relationship together. Now let's check b. So, or let's check c first. Let's skip b and then go to c. Now c, we said is the y-intercept, and then it's shifting the graph up or down. That is a vertical shift. Now let's try it. So we change c to the positive part. We expect the graph to move up along the y-axis. Let's change to the positive. Now let's move c. Now can you see the graph is moving up a bit? So when c is 1, the turning point and the y-intercept is 1. So if we move further to 2, so when it's 2, then it means the graph has shifted 2 units up. Then now can you see when you take it to the negative, so 0, then now it becomes negative. Now the graph is shifting down. Can you see the graph is shifting down a bit? So already when the value of c becomes negative, then the graph is shifting downwards by those units that were applied. So here is -2, so it means the graph has shifted down by 2 units. So that is the effect of c. Right, now let's go and put c0. Now let's see the effect of b. So the effect of B on the parabola. So I said it will go with the together with A. Now when A is positive, and then let's check if B is positive, but it shows that B will show the movement of the graph, especially for the turning point, the axis of symmetry, because B is kind of responsible for the axis of symmetry together with A. Then they'll shift the graph either left or right. Let's shift that. So let's change B to be positive and see what's happening. Can you see? The graph is shifting to the left when B is positive. Can you see the movement to the left? And at the same time it's going down a bit, because after getting the value of x from this B, which is the x at turning point, it will also affect the y value. But the main thing that the turning point in this case, if it's 0, then now look at when B is positive and A is positive, then the value of the turning point is in the third quadrant. Now if B is negative, then the value, and A is positive, then the value of what? The value of the turning point will be in the fourth quadrant. Can you see that? So meaning that from 0, as long as the graph is concave up, meaning that A is positive, so it means the turning point will be on the left hand side if B is positive. Then if B is becoming negative, then the turning point will be on the right hand side of the y-axis. Right, now let's change B with the negative A. Now let's change with negative A. Put any value. Now it's negative A. Now let's see B. So if B is positive, can you see that? Now the graph will still be in the left and the right hand side. But in this case showing to be in the first quadrant. Then now if the A and B are both negatives, then it means the graph, the turning point value of x will be on the left hand side of the y-axis. So meaning the value of the turning point of x will be negative. And then again, if A is negative, B is positive, the value of the turning point of x value will be positive. So we can play around this. When we're given an equation, you now know what is happening, where will be my turning point. Right, now that is kind of the horizontal shift. Now, alright, let's put A back to positive 1. Then B, let's make it also positive 1, like this. Then now it means A and B are positive. Then of course look at the turning point is on the negative x value. Now let's shift the y value, because you can see that the y-intercept here is 0. Now let's shift it. You'll see it also shift what? The turning point. So if it goes to 1, can you see the turning point is also shifting? So the turning point for y value is also shifting in that case. But you can see that, okay, in that case our C is our y-intercept, so that's why the graph is cutting y value at 1, and then but the turning point has also shifted a certain unit upward. So can you see that when the value of C is going up, then the whole of the graph will shift upwards. And then now of course we can see that if the value of C is increasing to as a positive number, the graph will continue shifting up. So if the value of C is being negative, the graph will continue shifting down, shifting down, up until to negative infinity. The graph will keep on shifting down if the value of C is negative. So the whole of the graph is shifting, not only the y-intercept, even the turning point is shifting in that case. So that is the effect of the parameters. How do they behave if you need to sketch a graph? So, but the important thing is the signs. So, or what if the c is positive, then the graph you can see will be above there. Then if it's negative, you can see that the y-intercept will be under. So the same thing, of course, can happen when a is negative. So when a is negative, in that case, so the c will also do the same. So when you shift to positive, the graph will still go up. When it's shifting down to the negatives, then the graph will simply go down, move down. So that is the translation of the parabola with these parameters here. So that's how our parabola is being affected. So let's learn that and see the effect of every point or every coefficient there. So this is what we have about the shifting of parabola. Now I hope you can see which variable, which parameter is affecting the vertical and the horizontal shift of the graph. That's it for this type of parabola.